Lesson 8.4 is the equations of sinusoidal functions. When we're looking at an equation for a sinusoidal, it's in the form y equals a sine, in brackets, bx plus c plus d. So a actually represents our amplitude. B represents a way of finding our period. So B, if you want to solve our period, we would actually put, if you're in radians mode, 2 pi divided by your B value is equal to your period. And then that could also be equal to, in degree mode, 360 degrees over B. So those are two ways that we can use B to find our period. C is the horizontal movement, left-right movement to get us to a certain point. So this is called a phase shift. We call this a horizontal translation as well. And D is our midline or our median. So that's our halfway point, the halfway distance between your maximum and your minimum point. Example number 1, they're giving us an equation that is a swing over time where h represents your height and t represents your time in seconds. What is the highest point the swing will reach? Well, to find our maximum, we can use a method where we take our midline and add our amplitude to it. So our midline is always our D value. Our amplitude is our A value. So if we take 65 and add 15, that's going to be our maximum height that we've reached, and that's going to be 80 centimeters for this. Now they're saying determine the height of the swing at 3 seconds and 8 seconds. So what we can do is we can substitute time as 3.5 and time as 8 to find out the height of the swing. So we can find height, which is equal to 15 cos. Now you have to be in radians mode if you want to get the right answer. So you're going to go 2 pi over 3, and in brackets you're going to put 3.5. And you're going to add to this answer 65. So that should give you an x value of, or a y value of 72.5 centimeters. Now you're going to repeat that, and instead of t being 3.5, you're going to put then 8.0 into that spot of t, and you should solve that the answer is 57.5 centimeters. So they're saying in terms of the movement of the swing, determine or explain what 65 represents. 65 represents your average height above the ground. And 15 represents the amplitude, which is the radius of this swing. Suppose the girl in the photo is at the highest point. How long will it take the swing to reach the point again? So this is where we can go and use our 2 pi, since we're in radians, divided by our B value. So we're going to have to divide this answer by what is in front of t, which is 2 pi over 3. So this is our B value right here. So we need to take 2 pi divided by B. So to solve that 2 pi, we're multiplying it by the reciprocal of that second fraction, 3 over 2 pi. That will cross these 2 pi's off, leaving us with an answer of 3. So that's going to take us 3 seconds for the swing to return to its original highest point. They want us to write a domain that would represent 2 cycles. So a domain would be where we go over 6 seconds, because 1 cycle is 3 seconds, 2 cycles would be 6 seconds. So time can go from 0 up to 6 seconds because we're just doubling the period. T can be an element of real numbers. So that's our domain, and our range would be height. Now, our lowest height can be found by taking your midline and subtracting your amplitude. So if we take our midline, which is 65, and subtract 15 from that, that's going to give us our minimum height of 50. So that's our smallest height. Our maximum height is what we found for the answer for A, which was 80. And then H can be an element of real numbers. So height is allowed to be in decimals. So that would be our first question. Question number 2, we have a Ferris wheel that has a radius of 8 meters. Radius means amplitude. The center is 10 meters above the ground. This is our midline. The rider gets on the chair of the Ferris wheel at the lowest point and completes a full revolution in 48 seconds. This is our period. So we're going to use that to draw what this looks like. So for height, we're going to go up by 2. And along your x's, we're going to go by 5s to be able to fit 2 cycles in. Okay, so our midline we know is going to be at 10. So that's our halfway point. We know that we're starting at our lowest height. So here, if we want to find our minimum can be found by taking your midline and subtracting your amplitude. So if we take 10 and subtract 8, that's going to give us a minimum height of 2 meters off the ground. So we're going to start our Ferris wheel at 2 meters above the ground. And then that's going to repeat. It's going to return to that same starting point 48 seconds later. So at 48 seconds later, approximately that, put another height at 2. So that's going to be the minimum of your graph. Now we need to find our maximum. Our maximum is where we take our midline and add our amplitude. Our midline is 10 and we're adding 8 to get 18 meters for our maximum height. So halfway from 0 to 48 should always be your maximum. So the halfway number between 0 and 48 would be 24 seconds. So at 24 seconds, you're going to plot a point at 18 height. And then what you're going to do is then draw your shape like a wave connecting those 3 points. So that's one cycle. Now you need to repeat that. So our highest height was at 24. If you add the period, which is 48 again, we know that 24 plus 40 is 72. So at 72, we're going to return to that maximum height again. And our minimum height was at 48. So if we add another 48, it's going to return to that minimum at 96. So we can use those that period to help us draw what this is going to look like, and that would be 2 cycles. So our amplitude was equal to 8 meters. Our period was equal to 48 seconds. And the equation of the midline is in the form y equals 10 meters off the ground. So that's what we were given in the question. Now they want us to write the equation of it. A is our midline, A is our amplitude, so 8 sine, and then B can always be found by taking 2 pi divided by your period. So 2 divided by 48, we're going to simplify it by pressing math, enter, and we're going to get that it's going to be 1 over 24. So pi over 24 is our B value. And then we're going to put minus 1.57 because that's given, so that's our phase shift given. And our D value is our midline, which is 10. So that's what the equation should look like if you're trying to recreate it by putting the numbers in the right spots. Example number 3, they're asking us to match which equation matches the picture here. So what I'll do is I'll look at where the midline is. If you count, there's 4 blocks above and below our midline is at y equals 1. So as you can see, graph number 1 could be either I, 2, it should be either 1, 3, or 4, because midline equals 1. And then that's also the case for graph number 2. Graph number 2, midline is 1 as well. So we know that we can cross off graph number 2 because that won't work for either of them. The next thing we want to look at is we want to look at cos versus sine. Cos, that's the only actually we'll look at one more thing. We'll look at the b value. The b value for the first graph is where you take your period, so I'll trace out the period. So as you can see, it's starting at 1. When does it return to 1 after going through and going to the minimum and then maximum and returning again? So you can see it returns to 1 right there, and that would be 90 plus 30 degrees. So it's a little past 90 degrees, 1 block afterwards, which is 120 degrees. So 360 divided by 120 is equal to 3. So we're in degree mode, so we have to use 360 instead. So we know that for graph number 1, the b value is 3. So again, that matches either graph number 3 or graph number 4 only. So now we're down to 2 choices for graph number 1. And then our b value for this one, if you guys trace it out, it's going to start there, come back. So it's going to go up to the max, down to the minimum, and return, at 360. So 360 degrees divided by our period of 360 gives us 1. So that means that graph number 2 matches I, because as you can see, there's a 1 even if you don't see it in front of there. Another reason why this is the graph number 2, is that because our maximum occurs, if you guys look at it, at 90 degrees. So normally the maximum for cos should always be on the y-axis. So that means it moved 90 degrees to the right, which is why we have negative 90. So whenever we're going to the right, it's negative. And how many degrees did we move to the right? That maximum should have been on the y-axis, so it moved 90 degrees to get to its position right now. So this one is graph number I. And now let's look at cos versus sine. So cos, remember, the maximum should always be on the y-axis, and if you look, the maximum occurred right at 90. So that doesn't match the values that I have right here, so that means it can't be graph number 4. Now, to figure out what sine is, or how sine has moved, what we're looking at is we're looking at the midline where it goes up from the midline. So as you can see, the midline where it goes up occurs right here, and we're figuring out how far that is from your y-axis. 1 block is 30 degrees, which means that 2 blocks is 60 degrees. And so that means that it moves 60 degrees to the right for sine. So our graph has to be number 3 for graph number 1. So that is our answer. Okay, so you can always graph these graphs and see which one matches accurately. So that would be another way of checking your answer. And then we have example number 4. So this is where we're going to want to use our graphing calculator. We're going to have to graph this and be in radians mode. Okay, so when you're in radians mode, you're going to use the window for x being 0 to 365. going up by 1, and your y window will have to go from 0 to 24, going up by 1. So when you graph this, they want to know the shortest day of the year. The shortest day of the year, so they want to know how many hours of daylight occur in Iqaluit on the following days. So the shortest day is like your minimum value. So your minimum can always be found by taking your midline and subtracting your amplitude. Okay, so you can do this graphically as well. You could find that minimum by going second trace number 3. So our midline is 12.585, and we're subtracting our amplitude of 8.245. And for our longest day is our maximum, where you can go midline plus amplitude. So you're going to take those same two numbers and add them instead. Okay, so 12.585 subtract 8.245 equals 4 hours and 34, so 4.34 hours of daylight. 12.585 plus 8.245 gives us 20.83 hours. So in some years, June 21st is the longest day, which is where you're going to have 20.83 hours of daylight. So they're saying, suppose the sun were to set at 11:01 p.m. What time did the sun rise? So we need to figure out 20.83 hours before that. Step 1 is changing this to the 24-hour clock. So 11:01 would be 23:01 on the 24-hour clock. And then what I'll do is I'll subtract 20 hours from there. So far we know that we're at 3:01 a.m. so far. Now we still need to figure out what 0.83 hours is before that. So we're going to convert this to minutes by multiplying by 60. So that gives us about 50 minutes. So we need to find out what is 50 minutes prior to 3:01. So this would be like saying 2:61. So that's like saying 2 hours and 61. If we subtract, so that's equivalent. 2 hours and 61 minutes is equivalent to 3:01 a.m. So now we're going to subtract 50 from this. And it makes it easier to do a subtraction here if we convert that 3 o'clock hour into minutes. So that's why I changed it to 60. Now if you subtract them, you'll get 2:11 a.m. So that's the time that the sun actually rose. What is the period? So the period in this case is where you take 2 pi divided by your b value. Our b value is the value right after sine, which is 0.0172. If you put that into your calculator, it's approximately equal to 365, which means that this is the rotation of the Earth. So this is what the period is. How does it relate to the context of the problem? Well, this hours of daylight will repeat every year. So every year, because that's 365 days in a year. And now they're saying, what does C of 80.988 represent? Well, this is where, for sine, that we're at the midline. So when are we at average temperature? Well, that would occur in spring. So we know that the lowest temperatures would occur at winter, the highest temperatures would occur at summer. So what would be between that? Well, that would be spring. So spring is when we're at, and spring, because the temperature has to be going up from there, so it has to be spring season. Now, suppose that the sun rises at 9:22 a.m. At what time did the sun set? So we're taking 9:22 a.m. and adding the amount of hours of sunlight there are when it comes to the shortest day of the year. So we're adding 4 hours and 34 minutes to this. So if we add 4 to 9, we get 13 o'clock. Well, there's no 13 o'clock. Well, we can write it for now. That would be the 24-hour clock. And then 22 plus 34 equals 22 plus, oh, actually, we need to convert this 34 first, 0.34 to minutes by multiplying by 60. So that's going to give us 20 minutes. So we know that it's 4 hours and 20 minutes after 9:22. So that's going to be 13:42 if we're on the 24-hour clock. Well, 13:42 is the equivalent of saying that it's 1:42 p.m. So that would be on a regular clock. So that would be our final answer for question E. So that is lesson